These notes are on the summary of modules 1 through 3 for Math 3. This is part of the activity that you did in the very first section of module 4. So we're just going to fill in this table talking about the various functions that we have studied so far: linear, exponential, logarithmic, quadratic, polynomial, and square root. We're going to talk about how to find roots, the end behavior, asymptotes, and domain for each of these 6 types of functions. So for linear, in order to find the roots, we set to the equation, set y equal to 0, and solve. And that's the same process for exponential and logarithmic. And quadratic, with one little catch, and use I'm not going to have the catch here be, and solve. Remember, when you're solving quadratics, you can use completing the square, quadratic formula, factoring with zero product property. So that one has many options. Polynomial, you set y equals 0 and solve. And square root, the same thing. So in order to find the roots, every single time we're setting the equation equal to 0, y equal to 0, and we're solving for x. And sometimes we get roots that are real, and sometimes we get roots that are imaginary or complex. It just depends upon what our function is doing. End behavior. For linear, we will always have it either be negative infinity to infinity, or infinity to negative infinity. That our end behavior is always going to be in the opposite direction of each other. Exponentials. Exponential has one end always going. Exponential is always going to have an asymptote. And so I have one end that can be getting very close to a value, and the other end can be going to negative infinity. Or I can have one end being close to a value and the other end going to positive infinity. This is reading this left to right. Logarithmic, same scenario. So same as the exponential. Quadratic, either we have both ends being positive infinity or both ends being negative infinity. Polynomials, if I have an odd polynomial, and we'll make our simplest one, I can have a positive infinity and negative infinity, or going the other direction. Negative infinity, positive infinity. And if it's an even function, then I would have the same behavior as quadratics. In this case, the odd and the even refer to the highest power on the polynomial. And square roots kind of have this stopping point, and then either, whoops, that's a funky looking function. And then either one side is going to positive infinity or negative infinity. But they do have a stop at one end. Asymptotes. So the functions we learned in Math 1, the linear functions have no asymptotes. Neither do quadratics, neither do polynomial. However, we do know that exponential has an asymptote, and we didn't necessarily talk about it that much in Math 1, but we know from our experience now with logarithmics, logarithmic functions, that if I have f of x equals a b to the x plus c, that my asymptote is going to be y equals c. And for logarithmic, if I have a log x plus b, then my asymptote is going to be y equals negative b. Oops, sorry, x equals negative b. Polynomials and quadratics don't have one, and actually neither do square roots. It looks like they start to flatten out, but they actually never do, because the square root of 10 is going to be smaller than the square root of 50, which is smaller than the square root of 1,000, etc. It does continue to get bigger and bigger. So the domain for exponentials and linears can be all real numbers. That's true also for quadratics and polynomials. Logarithmics, however, are going to have a stopping point, it's a starting, and then they'll go to infinity. And for square roots, it's the same thing. We have this, this place where the graph starts and then it goes to infinity. And of course, it can be the opposite infinity if it's facing the other way. So it could be negative infinity to b, negative infinity to b, one or the other.